Hello everyone, welcome to another video. Today we are gonna solve count pairs with given sum. In this question, we are given an array of n integers where we will also be given a integer k and we have to find out the pairs or the number of pairs whose sum is equal to that number k. For example, n is equal to 4, meaning the array contains 4 elements and we have to find all the pairs whose sum is equal to k, which is 6. Here 1 plus 5 is equal to 6. This is one pair. Then 5 plus 1 is also equal to 6. This is two pairs. We are not gonna repeat the pairs by changing the positions. So there are only two pairs whose sum is equal to 6. So the output is 2. For solving this question, we have brute force approach and the optimal approach. First, we are gonna see the brute force approach. So in the brute force approach, we actually find all the pairs and check the sum of those pairs is equal to k or not. If the sum is equal to k, we are gonna just increase the count. Otherwise, we are just gonna leave that pair. So here, the count value will be in starting equal to 0. Now, we are gonna start making pairs. So I will be here and j will be here. 1 comma 5 is a pair and it is a pair that is making a sum of 6. So we are gonna count this and our count becomes 1. Now j comes to the next position. 1 comma 7, that is 8, not equal to 6. J will be moved to the next position. 1 plus 1, it is 2, not equal to 6. I will move to the next position and j will come here. So 5 plus 7 is equal to 12, not equal to 6. J move to the next position. 5 comma 1, that is 6. We are going to include this pair and the count becomes 2 and j comes out of bound. I will move to the next position. 7 plus 1, not a pair. I will move to the next position and there is no pair to be found here. So the total count is 2 and we have found our answer, that is 2, which is the number of pairs whose sum is equal to 6. So the time complexity of this algorithm is big O of n square because we are looping and finding all the pairs, and the space complexity is big O of 1 because we are not using any other space. Now with this approach, the interviewer will not be happy. So he will want you to optimize this approach. Before we tell you the optimized approach, there is a middle approach or the average approach, which is sorting the array. When you sort this array, the array will become like this. Here 1, 1, 5 and 7. Now we are going to use two pointers approach, which is we will put I here and j here and we are going to traverse one by one. So 1 plus 7 is actually 8. Now 8 is not the desired answer, so we know that the sum is actually greater. When the sum is greater, we are gonna just decrease j, so the j will come here. Now 5 plus 1 is equal to 6. Now the count will become 1. Now we will just increase this I, so the I will come here. 5 plus 1 is again 6, so the count will become 2, and when we increase I and j at the same position, so the condition is if I and j is at the same position, then we are going to stop. So our count becomes 2, and this approach takes time complexity of big O of n log n. Now let's move ahead to the optimized approach. So to understand the optimized approach, we are going to take two different examples and we are going to use hash map. So let's just think this container type thing here is our hash map. So let's take our first example. We are going to start from the first element and we are going to traverse this array and we are going to subtract the first number with the element k to find what is the second number that we should have. If that number is present in the array, then we should also have gone through while traversing and we should find that number in this container or that hash map. Now the first number is 1, so k is 6. 6 minus 1 equal to 5. We don't have a 5 here, so we are gonna move to the next element and we are gonna store this here. So what is the frequency of 1? That is only 1. Now what we have? 5. 5 minus 1, 6 minus 5 is equal to 1. We have 1 here and the frequency is 1. So we are gonna increase the count, which is basically 0 to 1, the frequency. Now let's move to the next place, that is 7. 6 minus 7 is equal to minus 1. First we have to also put 5 here. and the frequency is 1. So minus 1 is not in this hash map. So we are going to move to the next place and we are going to put 7 here. 7 comma 1. And we got 1. 6 minus 1 equal to 5. We have a 5 here and the frequency of 5 is 1. So we are going to add 1 here. So we have a count of 2 and we are going to increase the frequency of 1 as we have encountered 1 here. So this will become 2 and we are out of bounds. The total answer is 2 here. So now let's see the same approach with another example, that is 1 1 1 1. So we are going to start at the first place 1, and for this example let's take k equal to 2. Now do the subtraction from the kth element to the element that we have. The answer will be 1. We don't have a 1 here, so we are going to put this 1 here over here and the frequency is 1. Let's move to the second place. 2 minus 1 is again 1. We have a 1 here. So we have one pair, basically this one, and we are going to add this here. Now let's move to the third place, which is basically the index 2. We also have 1 here. 2 minus 1 is 1, but the frequency is 2 now because we have two ones now. So we are going to add this frequency to the count. Why? Because this one will make two pairs basically, that is one this pair and one this pair. So basically we have two pairs here. Now we are going to increase the frequency 1 comma 3 and we are going to move to the next pair, not the pair, next index. So we again encounter 1 and 2 minus 1 is 1. Now we have a frequency of 3. This means this one will make 3 pairs with the previous elements. 1 pair, 2 pair and 3 pair. So the total answer becomes 3 plus 2 plus 1 is equal to 6. So that's why we are gonna count the frequency and we are gonna add only the frequency to the count. So the time complexity for this algorithm is big of n and the space complexity is big of n in the worst case. Let's check out the code for this approach. For solving this question, first we are going to create a hash map, which is the syntax map of integer comma integer, and we are going to take a variable map and declare it as a hash map. After that we are going to take a variable count, which is basically 0. We are going to start the count from 0, of course. Now we are going to loop through the elements, and if map dot contains key, we are going to check if the map contains the key where k minus array of I. If it is inside the map, then we are going to get the value of that key and we are going to increase the count. So count plus is equal to map dot get k minus array of I. After this is complete, we are going to check if the element of array of I is inside map or not. If that is not inside the map, we are going to create an entry for array of I inside map and we are going to declare it as 0, because for every value we are going to increase the value in the next step. Now when we get all of this completed, we are going to just return the count. So this is the whole solution. Also this should be integer. Now we are gonna run this to see if there are any more mistakes here or not. Evaluating, and it is okay. Now let's submit this solution and check if we have the right approach. Problem solved successfully, meaning the approach is correct and the time complexity for this algorithm is big of n only, with space complexity of n. So let's meet in the next video. And also if you have any question, let me in the comments below. If you found this video helpful, please drop a like and subscribe to the channel. Also share this video as much as possible. Let's meet in the next video.